In the energy topic, there are loads of variables, and it's important you know the values and symbols of all of them. Energy is measured in joules, and the symbol is a capital J. Mass is measured in kilograms, and the symbol is kg. Speed is measured in meters per second, and the symbol is m/s. The spring constant is newtons per meter, and that's n/m. Extension is standardly measured in meters, and again is m. Height also in meters, with the symbol m. Gravitational field strength is measured in newtons per kilogram, n/kg. Temperature change is measured in degrees Celsius. Specific heat capacity is the tricky one to remember. It's joules per kilogram per degree Celsius, J/kg degrees Celsius. Power is measured in watts, and the symbol is a capital W. And time is measured in seconds, and the symbol is S. You also need to know the names of the different types of energy stores. For example, there's magnetic, which is the energy stored when repelling poles have been pushed closer together, or when attracting poles have been pulled further apart. There's thermal energy, or internal energy, which is the total kinetic and potential energy of the particles in an object, and in most cases this is the vibration of the particles. Chemical, which is the energy stored in chemical bonds, such as those between molecules. Kinetic, which is the energy of a moving object. Electrostatic, which is the energy stored when repelling charges have been moved closer together, or when attracting charges have been pulled further apart. Elastic potential, which is the energy stored when an object is stretched or squashed. Gravitational potential energy, which is the energy of an object at height. And finally, nuclear energy, which is the energy stored in the nucleus of an atom. The first law of thermodynamics states that energy can be transferred usefully, stored or dissipated, but cannot be created nor destroyed. You need to recognise energy transfers in the following examples. An electric kettle transfers electrical energy into thermal energy to heat the water. A battery-powered torch will transfer chemical energy into light energy, which will then be dissipated as heat. A skydiver diving transfers gravitational potential energy into kinetic energy as they fall, and a car crashing into a wall will transfer kinetic energy into heat, sound, and light energy. In the energy topic, there are a lot of keywords that you need to know. A system is an object or a group of objects. Kinetic energy is the energy that's associated with a moving object. The elastic potential energy is the energy associated with an object that stretches or can be compressed. Gravitational potential energy is the energy associated with an object that's been raised. Specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Power is the rate at which energy is transferred, or the rate at which work is done. In a closed system, this is a system where energy can either enter or be lost. Dissipated. This is in a system where energy is stored in less useful ways. It's often described as being wasted. Renewable resources are resources that are being, or can be, replenished as they're being used. And non-renewable resources are ones that cannot be replenished as they're being used. The energy topic contains a lot of the formula that you need to learn. Let's go through them now. Kinetic energy equals half multiplied by mass multiplied by speed squared. The elastic potential energy equals a half times the spring constant times the extension squared. GPE equals mass times gravitational field strength multiplied by height. The change in thermal energy equals the mass times the specific heat capacity multiplied by temperature change. Power equals energy transferred divided by time, or power equals work done divided by time. These are both divided by time because they're rates, like in the definition on the left-hand side. Efficiency equals the useful power output divided by the total power input, or efficiency also equals the useful output energy transfer divided by the total input energy transfer. In the Sankey diagrams above, the most efficient device is the one on the right. This is because it has a less proportion of waste energy and more useful energy. You might be asked how to make some devices more efficient. Common examples are included here. To reduce the loss of heat in a coffee cup, you could put a lid on the coffee cup. If there's friction between the brakes and wheels of a bicycle, then you can use oil as a lubricant. Sound created by a vibrating washing machine can be reduced by fixing those parts to reduce vibrations. And a building that's losing a lot of heat can have thermal insulation added to it. You also need to know the advantages and disadvantages of a range of energy resources. We'll go through them now. Energy resources include fossil fuels, which is non-renewable. The advantage of fossil fuels is that the infrastructures are already in place, but the disadvantage is they release lots of CO2, which causes global warming. Another energy resource is nuclear, which again is non-renewable. The advantages of nuclear include it has a small carbon footprint, but the disadvantage, it produces radioactive waste, which has to be got rid of. Biofuels are renewable resources. The advantage of these is they are generally carbon neutral, but they do take up land that could be used for food production. Wind, again a renewable resource, is very cost effective, but it is dependent on the wind. Hydroelectric, again, is renewable, and the advantage is it's reliable. Dams will always be there, but it can affect the habitats by flooding and disruption of river systems. Geothermal, again, is renewable and again is reliable, but some locations are better suited to this than others. Tidal energy, again, is renewable, and the advantage is reliable. There's always 2 tides a day, but it can block sewage that needs to go out to the sea. And finally, solar, again, is renewable and works well at a range of scales. However, it's dependent on the sunlight.